Welcome to Math with Wong. Today we're going to look at number 5 of the May 2024 standard level paper 2. You can see that you're given a sine function. However, it's also talking about velocity and displacement, right? So it's a kinematics application question. What's given here is the velocity function, and it's some sort of sine graph, but it's also combined with a polynomial function here, right? So let's take a look at the question. A, to find the smallest value of t when the particle changes direction. As I said in class, this is one of the most common questions that they ask. You need to remember what it means. When a particle changes direction, it means velocity is equal to 0. That's what it means. So they give you the graph, and this is via t. So that means I want this point and this point. But they ask for the smallest value, so smaller of the two. So I'm looking for this dot here. Now, this being a paper 2, I'm going to use my graphing calculator, right? You're going to find this. You can type it in y1, 2 sine 0.5t plus 0.3t minus 2. Again, make sure your mode is in radians. And you can find this x-intercept. I use my graphing calculator, rounded off to 3 sig fig. This point is t is equal to 1.69 seconds later. Okay. Derivative equal to 0. So velocity equal to 0. That's when it changes direction. Part B, find the range value of t for which the displacement is increasing, right? So you can think of it as the original function f at x is increasing. F at x is increasing is when the derivative is positive, right? So the displacement is increasing means I want the velocity function is positive. A positive greater than 0 means above the x-axis, right? So where is the graph above the x-axis? Well, it's between this point and that point. This is when the velocity function is above the x-axis. So I'm looking at this portion between these two x values. They want a range of values, so we're looking at between those two numbers. So I'm going to do the same thing as what I did in part A, but now I'm looking for this x-intercept. So again, second trace 2, and you can find the second x-intercept. And I use my graphing calculator, and I'm getting 6.12 seconds. So for part B, I want in between those two. So it's going to be 1.69 less than t less than 6.12. During or between 1.69 seconds and 6.12 seconds, the particle displacement is increasing. Okay. Part C, find the displacement. Well, you're given the velocity and you're finding the displacement, which means I need to do integration. So part C is an integration question. T equals to 10. So I'm going to integrate and substitute t equals to 10. Let me copy down the equation. 2 sine 0.5 t plus 0.3 t minus 2. I'm integrating this, so dt. I want to find the displacement when t equals to 10. So I need to know where is at 10, subtract where is at 0, right? And that's the displacement. That's going to give me the displacement after 10 seconds when t is equal to 10. Now I can do this by hand, but because this is a paper 2, I'm not going to worry about that. So what I'm going to do is I'm going to use the graphing calculator. So the function is second trace 7, I believe. Let me check. Yes. Second trace 7, which is the integration sign. And we're going to put in 0 and 10, lower and upper boundary. Press enter. And I'm getting a negative value, right? Some people say, do I change it to positive? No, because this is the displacement. It's not distance travel. If it's distance travel, it's always going to be positive. But when we're looking at displacement, it can be positive or negative. So if you look at it, at t equals to 10, right? You're definitely going to be at a negative value. But if you overall, right, this part is negative, this part is positive, this part is negative. So the overall negative is more than the positive. So the overall displacement is going to be negative. Right? And you see how this is going to be below the x-axis. It's going to be negative. So the correct answer would be negative 2.13 meters. Okay, thank you for watching.